Hi guys, welcome back to my channel. In this video, I'm going to discuss about the instruction codes, and there's the second part. We have completed with the digital computers, and now we are going with basic computer organization and design. And there's the first thing in our syllabus copy, that is instruction codes. Let's see what are the instruction code means. The instruction code is a group of bits. Instruction code is a group of bits that instructs computer to perform a specific operation. Instruction is nothing but instructs the computer to perform a specific operation. But what instruction code means, the instruction code is a group of bits. Code is nothing but group of bits. So that we can understand that a group of bits that instructs the computer to perform a specific operation is known as instruction code. And operation code of instruction is a group of bits that design such operations as add, subtract, multiplicate, shift, and complement. We know that, so here we have seen that code is nothing but group of bits. The operation code also code is an instruction is a group of bits. Define operations nothing but add, subtract, multiplicate, shift, and complement. Everything will come under the operations. So operation code is nothing but group of bits that define such operations, subtract, add, multiply, whatever the operation is, that is the operation code. The operation code must consist of at least n bits for given 2 power n distinct operations. This is the most important point in the operation code. The operation code must consist at least n bits for an uh, given 2 power n operations. That is, if you are having n bits, there will be 2 power n operations. Okay, or that can be said in vice versa way. If there are 2 power n distinct operations, then there should be at least n bits. Okay, now stored program organization. Stored program organization. We know that organization nothing but which deals with the structure, architecture is structure. Organization nothing but which deals with the designing and the process, right? The simplest way to organize a computer is to have the process register and the instruction code format with two parts. See, let's understand this computer organization. The computer organization is designing and its function. We know that. The stored program organization means, stored program means what? Storing a program. Simplest way to organize a computer is to have one process register and an instruction code format with two parts. That is, see here, the operation code is of one part and the address of the stored program, that is of other part, that is instruction format. Okay, the first part specifies the operation to be performed and the second part specifies the address. This way. Okay, this is a binary operand, that is 0 to 15. And there's the address 0 to 11 and operation code will be from 0 to 15 in the instruction stored program organization. This is the instruction program and operand data. This is the memory of size 496 into 16 bit. Okay. Now, let's see about the accumulator. What is meant by accumulator? A computer has a signal processor register usually assigned in it the name of accumulator. See, the computer have signal processor register usually assigned to it the name accumulator. The operation is performed with the memory operand and the content of accumulator. Accumulator is nothing but signal process register. Usually the signal process register is known as accumulator. It's simply called as accumulator, signal process register. Okay. that is which gives the signal to process the register is known as signal process register or as accumulator, short form AC. The operation is performed with the memory operand and the content of AC. Through the memory operand, and this accumulator will be giving the signals to the register, so that can provoke the address, so that the operation will be done. So the operation code will be done. The operation code have to be done with the operand, right? And the content of accumulator, which is the instructions are given. Indirect address, it's sometimes convenient to use the address bits of an instruction code not as an address but as the actual operand. Instead, providing address, sometimes it is convenient to use the address bits of the instruction code not as the address but as the actual operand, which means the providing, instead of address we can provide the address bits, the actual operand anamata. Sorry, I'm using my native language in between, don't get confused. When the second part of instruction code specifies an operand, the instruction is said to have intermediate operand. When the second part specifies the address of operand, the instruction is said to have the direct address. See, addresses of two types, direct address and the indirect address. When the second part of the instruction code, in the instruction code, the second part is the address, right? When the second part of instruction code specifies the operand, the instruction is to be intermediate operand. Okay, immediate operand. Then the second part specifies of an operand. When this address is of specifying immediate operand, then this is indirect, and when it consists of instructions in form of bits is known as direct address. Okay. Effective address. Effective address is to be address of the operand in a computation type instruction or the largest address in the branch type instruction. The effective address is the best way of using the address or the target address in the branch type instruction. This is used in this so that we can easily get into it. Okay, demonstration of direct and indirect address. Let's see what direct and indirect address from this diagrams. See, the instruction format is having the two things, address part and uh, operation code. Okay, 0 to 11 it's given as address, 12 to 14 is the operation code, and there's the sign and matter. 15th bit will be, the last bit will be the sign. Direct address. Direct address is having the operand. Okay, see, if the memory is like operation code have to perform the operation, that is 0 add 457. This is performing the operation. This is opcode. Okay, the operand. The operand is sending signal, that is plus to the accumulator. Accumulator, that is plus, which is giving the operand for 457th bit, so that we will be adding. This is direct memory. Whereas in indirect memory, here the 35th bit, in the 35th bit we are adding 1 add 300, and this is the address of 1350 1350, and that is of that has the address 300. This address is written here, but here the direct operand is written here. Okay, whereas this 1350 operand consists operand. Okay, that is here directly one step operand here in the direct, whereas in indirect there are two there are two steps to get the operand. Okay, first here is written as the address for the another address, and that address consists of operand that will be sent to the plus, and that will send to the accumulator. Accumulator will send again the positive signs, that is sends the signals, that is instruction format, direct address and indirect address. Let's see all these things in the next video. Thank you.